This is Professor Pelton. This is Trigonometry, Chapter 1, Section 3 on the unit circle. Make sure you watch the unit circle video prior to doing this lesson. So the equation for the unit circle is x squared plus y squared equals 1. Normally the equation is x squared plus y squared equals r squared, but r is 1 since it's a unit circle, unit being 1. It doesn't matter if that 1's an inch, a mile, a foot, a yard, doesn't matter, it's just 1, it's the basic unit. Okay, so we have points on the circle that are p. Each one is a cosine value and a sine value, as we'll show you in a little bit. And the arc length and the angle are the same. The reason being, if you do the formula for arc length, right, it's s equals radius times the angle, right? But if it's a unit circle, r is 1, so it's s equals r times theta, or 1, right? So the s equals the theta, right? Where s is right here, and your angle is theta is right there. Okay. And notice the coordinates that go around are the distances of 1 also. So you have negative 1, 0, 0, 1, and 0, negative 1. Okay. Of course, the ones in between we covered in the unit circle video, right? Which are infinite numbers in between, but we've covered some specific ones in the unit circle video. Okay. So the unit circle has a corresponding point, and those can be positive or negative depending on what quadrant they're in. Obviously, this is positive, positive here. This is a point over here, would be positive, negative. Over here, of course, is negative, negative. I don't know what's going on with my pen there. That should be a 1. That should be, it's going in the wrong direction. Oh, I did it twice. And of course negative, positive, okay, whatever the coordinates are on the circle you happen to hit. Alright, and the angle can be both positive and negative. Okay, alright, so how are we going to define the coordinate, the trig functions based on this coordinate on the unit circle? So they are based on ratios of the sides. So this is actually r, y over r and x over r, because we said if we have this unit circle, we have a coordinate that is x comma y, which is cosine comma sine. But since r is 1, you don't really need it, correct? Right? But if you want to get from here to here, you do need it, because y over 1 flipped is the 1 over y, which is the cosecant. So this is cosecant, and this is secant, right? And then the other one is cotangent. So those are our 6 trig functions. Okay. Next page. So let's say we have a coordinate on a unit circle given to us by an angle, and that coordinate is negative 1/2 comma root 3 over 2. So that is our cosine comma sine, which is our x and y value. Sine is defined by the y value, which is the root 3 over 2. The cosine is divided by the x value, which is negative 1 over 2. And those x and y definitions are on page 1. And tangent is defined as whatever angle you're doing, which in this case is angle t, right? So t is the angle, is defined by y over x, or in this case root 3 over 2 over negative 1/2, which is the sine over cosine. You notice those cancel, the 2's, so I'm left with root 3 over negative 1. And the other functions are the reciprocals. So cosecant is the reciprocal of 2 over root 3. Secant is the reciprocal of cosine, so that'd be 2 over 1. Keep the negatives on top though. And tangent is the reciprocal of cotangent, so that's 1 over root 3. And we should keep the negatives on top for prior. Okay, so pause the video, try these student problems. Okay, so we have another coordinate here in the first quadrant of an angle t. So that is our x, that is our y. The y is the cosine value. The cosine is the x value. So if we do y over x, we'll get tangent which gives us 1 over root 3. And if we reciprocate the functions, we're going to get cosecant, secant, and cotangent. Oh, I did that wrong. I'm sorry. I read that incorrectly. And it's root 3 over 1. And those are all just ratios of sides when you make the actual triangles here, right? As you saw in the unit circle video. All right, let's do one more student problem. Okay, so we have another coordinate here in the third quadrant, which is negative, negative. It still makes a triangle, right? We have an x value and a y value. The y value is sine, which is negative 4/5. The x value is negative 3/5. Tangent is y over x, which is negative 4/5 over negative 3/5. Cancels. The double negatives cancel, give me 4/3. I can reciprocate them. Get cosecant, secant, keeping the negatives on top, and 3/4. Okay. All right. Let's go to the next page. All right. So they don't always make nice little triangles. You can also get the quadrantal angles, which are the ones that fall on the actual axes themselves, which are going to be combinations of zeros and ones and negative ones. But if I look at that for a minute, we know that's supposed to be cosine, comma sine, so we put that in. We get 1 for sine and 0 for cosine. Okay, so we do y over x to get tangent, right, sine over cosine, which is 1 over 0. Okay, but 1 over 0 is not doable, that's undefined, right? You cannot divide by 0. But I need to reciprocate these. I can reciprocate tangent, right? I should keep it as 0, 1 over 0. So I can write it over here as 1 over 0, or 0 over 1, which is 0. Okay? But the other two, I need to reciprocate. So that's if I make those fractions, it's over 1, correct? So 1 over 1 is 1 over 1. 0 over 1 is 1 over 0. So in this case, you get 1, you get 1, we get undefined, and you get 0. Okay? Because the reality is, just because you have 3 lengths, you cannot make a triangle in all cases. You will get some undefined answers. All right, pause the video and try the student problem. Okay, so now we have a coordinate of negative 1, 0, which is our x and y. So sine is 0, and cosine is negative 1. We'll make those fractions. Actually, hold on, before we do that, let's actually do the tangent. So the tangent is the y over the x, okay? So we get 0 there. Make those fractions. We can reciprocate everything. 1 over 0, 1 over 1, just keep the negative on top, and negative 1 over 0. So that's 0. Can't divide by 0, so that's undefined. And I get negative 1, and undefined. Okay, so let's think about the applicable values for sine and cosine specifically. We're going to ignore the other ones for now. So, I'll plug that in. We're only focusing on sine and cosine because that is the values on the outer edge of the circle. Okay, where x is the cosine and y is the sine. Well, the input domain is the angle, which is t in these diagrams, or theta, depending on how you want to think about it. It doesn't matter what angle I plug in. Okay, I can plug in a positive angle or a negative angle, and I can go around the circle as many times as I want in either direction, okay, in positive and negative direction. So the reality is the input is negative infinity to infinity for the actual angle. So the question is, when you plug something in as far as an angle, right, this is t in this case, right? If you plug in an angle, what are the possible outputs? Well, the outputs are these coordinates on the circle, okay? So you're always on the unit circle. So the largest value you can be is 1. The smallest value is negative 1. And those are inclusive, because on the outer edges, right, you are the negative 1s and 1s. And the ones in between are the fractional coordinates, which you will learn in the unit circle video. Okay? Alright, so the question is, what do we have here for answers? Well, if I try to solve these, let's rewrite this way. sine of theta equals 5. So what angle will actually give me 5? Well, if I do inverse to both sides, which is how you solve an equation, right? You do inverses. Sine of theta and sine of 5. That'll cancel. So the angle equals the inverse of sine of 5, right? So let's see what happens in the calculator. Okay. Alright, so do the calculator. So, I don't need control. I hit the wrong button. Sorry. Alright, trig. So inverse sine of 5. And we'll hit the answer. Ooh, I got an error. Alright. No real result. Well, maybe it's because I'm in radians. I need degrees. Let's try degrees. So we'll try degrees. Okay, we'll go up and copy that. Control C. We'll go down and paste that. And hit it again. Oh, not a domain error also, right? Because there is no angle, essentially, if you look at this, there is no angle that will give you 5, right? So it's undefined, okay? There is no angle that will give you -2 for the other one either, right? Not possible, right? Not equal, okay? Because our range is -1 to 1. You can plug in any angle you want, right? Any angle you want, but you will not get anything beyond 1 and -1 for these x and y values on the circle. So thus the next two, the student problems, same thing. Not possible. Okay, those are not within the range of -1 and 1. Okay. All right, that is the end of part 1.